Okay, this is part 2 for day 18. I just didn't have enough time to finish, so I'm going to example 2 and then I'll do example 3. So this one will be a little bit shorter, but this is for, again, day 18, solving linear and quadratic functions. So on the top, I have a quadratic. On the bottom, I have a linear. I'm going to use those together to help solve. So I already have my arrow drawn here. I'm going to take that linear and I'm going to substitute it into that quadratic. So when I write this out, I'm going to have 2x minus 3 is equal to x squared minus 2x minus 3. Okay, what you want to do is on the left side over here, you want to get that set equal to 0. So I'm going to go ahead and move the 2x by subtracting it and move the 3 by adding it so that there's nothing over there. There's 0. And when I do that, that's going to leave me with x squared and then a minus 4x, and those 3's are going to go away. They'll cancel out. So now you have to solve it. You have a lot of options. You can do, let's see, you can do graphing, which would need a calculator or Desmos. You could do GCF and factoring. That was a while ago. You could do solving by square roots. That was more recent. You can do completing the square. That was the other day. Or you could do the quadratic formula. All of those are pretty specific. Quadratic formula is the one that works every single time. Okay? Once you kind of get better at this, you can kind of look at them and figure out, oh, I should use this, or oh, I like this method. But as I'm looking at this problem, I notice that I can use GCF factoring. So when I do that, I'm going to go ahead and take out a GCF of x. That'll leave me with x minus 4. That got rid of that quadratic. So I can do the ZPP, which means take each x and set it equal to 0. So that first one is x equals 0. So there's one of my answers. And this other one is x minus 4, set it equals to 0. I need to add 4 to the other side, and I would have x equals 4. And that's my other answer, which these are just normal numbers, right? No i's, nothing like that. I have x equals 4 and x equals 0. That means I have two real solutions. If I were to graph this, I could actually see the two places where they cross. Okay, my last one, number 3. I have that quadratic and I have the linear. I'm going to take this linear and I'm going to plug it in. So I'm going to have x minus 1 equals x squared minus 2x plus 4. Again, on the left side, I want to move those over. So I'm going to subtract x and I'm going to add 1. I want to set that equal to 0 over there. That'll leave me with x squared minus 3x plus 5. Again, I went through the spiel for the last problem, but you have a lot of different ways to solve. You have graphing, you have factoring, you have square roots, you have completing the square, and you have quadratic formula. The quadratic formula works every single time, so I'm going to go ahead and break this apart. So A is 1, B is negative 3, and C is 5. And I'm going to go ahead and scoot down, and I'm going to use my formula. So x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. And again, I'm focusing on this yellow part. I'm going to type that into my calculator. That double negative makes a positive. Underneath the root there, when I type that into my calculator, I get negative 11. So this is what I have so far. Two things I need to focus on is this negative would give me an I, and then I want to see if I can break apart the 11. The only thing that multiplies to 11 is 11 and 1, which that doesn't help me break that apart at all. So what I can do here is I can go ahead and have x equals 3 plus or minus. I can have that I come out. Root 11 is just going to have to stay, and then the 2's on the bottom. And that's actually as low as I can go. X is by itself, and I simplified everything I could. I have an I in my solution, which means there are imaginary solutions. I cannot see them on my graph. I don't know where they cross. So when I write this, I'm going to say there are no real, that's the key word, there are no real solutions. There are solutions. They're just imaginary. I can't see them. There's no real ones to see on the graph.